In this video, I'm going to talk about three-point perspective, and it's all in my book, Ellen's Guide to Drawing Shapes on Amazon. In three-point perspective, the line of sight is no longer horizontal. In this worm's eye view, we look up, so our line of sight is still perpendicular to the picture plane because the picture plane now tilts toward the viewer. For a bird's eye view, our line of sight, again, is still perpendicular to the picture plane, which now tilts up. Think of the line of sight and the picture plane as a unit that rotates around the eye, and eye level remains here. For three-point perspective, two of the vanishing points will be on eye level, and the third one lies between them, between here and here. And the angle from the vertical vanishing point must be less than 90 degrees. Now, as this vertical moves away from eye level, these lines become more and more vertical, and eventually it becomes two-point perspective. So two-point perspective is a special case of three-point perspective, where the vanishing points for these verticals are infinitely far away. So here I have the setup with the two vanishing points on eye level and the third one below with an acute angle right here. And our first job is to find the center of vision. And to do that, you find the lines from each vanishing point that are perpendicular to the other side. And when you draw three such lines, they intersect at the center of vision. If the angle here were more than 90 degrees, then some of these lines would go outside the triangle and we wouldn't be able to find the center of vision. To draw the box in three-point perspective, start with the front corner here and connect it to the two vanishing points on eye level. Then finish the square and have all these corners connect to the two vanishing points on eye level. Then connect all the sides to the vanishing point below. Decide where you want the box to end and connect these lines to the vanishing point on eye level. And you end up with a box where all the corners are connected to all the vanishing points. Here's a finished three-point perspective box, and let's look at its characteristics. For one thing, this bottom angle is usually less than 90 degrees, whereas with two-point perspective, it should be more than 90 degrees. The vertical sides usually converge the most. It creates a much more tense and unstable image than does one or two-point perspective, since the only part that is closest to the picture plane or to the viewer is this front corner. It's useful for images that are taller than they are wide, and it's used when the object is far below or above eye level so that we see its top or bottom more than we see the sides. The triangle connecting the three vanishing points could form an equilateral triangle with three equal sides. This is the smallest triangle you can draw, but it is boring and predictable since the three sides are equal. And also look at the front edge of the box and the back edge. They line up so it looks like a hexagon instead of a box. Instead, you should probably use a non-equilateral triangle since the box you get looks 3D. Three-point perspective, as you can see, takes a lot of space. Look how far away these vanishing points are to make this little box here. When the lowest angle of this triangle is just short of 90 degrees, then the center of vision is very low, meaning that the viewer is looking down at the box. He sees the top of the box, and the rest of it is greatly foreshortened, and he doesn't see eye level, which is out of his cone of vision. If, however, this lowest angle is very small, then the viewer is barely looking down at all, so the center of vision approaches eye level. He sees much less of the top of the box, and eye level is now in his cone of vision. The vertical sides don't converge very much, and this lower angle of the box is often more than 90 degrees. This is almost what we see in two-point perspective. Let's compare this small white box to the large yellow box. They have the same proportions because their converging lines are parallel. As the box gets bigger, its top gets larger relative to its side. So this top is very large compared to the sides that converge rapidly. For the small box, the top and the sides are almost the same size. If we were close to the tower, then it would look like this large yellow shape. This white one would be what we would see if the building were in the distance. A rough way to make a box in three-point perspective is to start with a box in one-point perspective. Find the center of the box by connecting opposite corners. Then determine where you want the new box to begin and have it ride up these diagonals. And at a certain point, pick a bottom that will be parallel to the bottom of the old box and connect these new corners to the corners on top. Now for the right side, we would normally have the box on this diagonal and go to these corners like this. But the problem is that this diagonal is on top of the left side of the old box. So what I did here is I moved it in a little bit so it looks like it slants. Now this isn't technically correct, but this is sort of a rough way of making a three-point perspective box. It works mainly when the box is near eye level because it's difficult to judge the convergence if the box is far from eye level. In my next video, I'll discuss drawing a house, and please remember to subscribe.